Okay, so hello YouTube. This is a video on SolidWorks with the title A Complete Introduction to SolidWorks in a Single Video. Now let me tell you, this video is going to be an hour long. So I will upload this video as a whole and also in two parts. Now let me tell you, this video is not to tutor you about the SolidWorks software, but to give you a complete introduction to all the capabilities of the SolidWorks software, of all the models, so that your interest develops into the software. Okay, so I have covered about 10 to 12 models in a single video. Like I've covered sketch, part design, assembly, material application, exploded view, motion study, surface, sheet metal, weldments, mold. Okay, I also included CAM, SolidWorks CAM. So I have completely, so it was very difficult to cover this all in detail in a single video. So this video is not for tutorial, this video is just for an overview so that your interest develops into the software. So now let me tell you what is the SolidWorks software. So SolidWorks is a design software, a CAD software for mechanical engineers. It is also used by the electrical students, but it is not used by the civil students. So it is only for mechanical and electrical. Okay, so this software is provided by the company named Dassault System, and the software was originally developed by the SolidWorks company, which was later on purchased by the Dassault System. Now the another very famous software which Dassault System provides is the CATIA software. Okay, so let me again tell you, the aim of the video is to give you an entire overview of all the models in the SolidWorks software. Okay, so hopefully your interest will develop into the software and you will enjoy. So let's start. So ये SolidWorks 2022, this is the starting page. अब आपके पास कोई भी SolidWorks तो चलेगा as long as it is about SolidWorks 2018. So first of all we'll take drawing. हम 2D ड्राइंग करेंगे फिर उसको 3D में कन्वर्ट करेंगे. तो जो फर्स्ट मॉड्यूल है वो हमारा 2D स्केचिंग है. सो आई गो टू पार्ट पार्ट आने के बाद मैं लिंक फ्रंट पे. नो लेट मी टेल यू, अगर हम यहाँ पे कस्टमाइज नहीं जाए तो अभी माउस जेस्चर्स नाम से ऑप्शन है. सो माउस जेस्चर्स आई एम यूजिंग व्हिच मींस दैट व्हेन आई विल क्लिक बाय राइट क्लिक तो मेरे पास ये ऐसा टॉगल है. ठीक है, और उस टॉगल में मैं कहीं पे भी जा सकता हूँ एंड आई विल स्नैप. सो आई एम नॉट गोइंग टू स्नैप द लाइन फ्रॉम हियर or circle from here. I'm just going to press my right click and I'm going to take line from here. Okay, so this increases the speed. तो मैंने ऐसी लाइन ड्रॉ की, then this, फिर इधर इसको ज्वाइन कर दिया, फिर इसको डिलीट कर दिया. आई एम जस्ट गोइंग वेरी फास्ट. So I just want to show you the capabilities of SolidWorks. ठीक है, मैंने went to revolve boss, इसको रिवॉल्व कर दिया. तो इसको रिवॉल्व तो किया लेकिन ये थोड़ा लॉन्ग चाहिए. Then I can also edit from here. Go to edit, make it a little bit longer. Okay, that much is good. Exit, then go to fillet. या फिर मैंने fillet किया. This much is okay. Then this space, sketch. Okay, फिर ये circle. I'm not giving any dimensions. This is a rough case. फिर ये इधर तक किया. फिर ये जो फीचर है इसको I will do circular pattern and that's good. तो मुझे जो है डिलीमीटर में मैंने शिफ्ट किया इसको. ओके, दिस वन स्केच सर्कल एंड नाउ विल डू डायमेंशन. सो आई थिंक 10 इज ओके एंड एग्जिट. फिर सर्कल को आई विल डू एक्सट्रूड कट. कट में करूंगा करीब 80 mm तक मैंने कट किया. ओके, सो दिस इज माय न्यू पार्ट. ओके, नाउ आई जस्ट मेक अ फोल्डर. so far I got triple A. Now I will just save this. Go to 3D drawings, triple A part 2 save. Okay, now we'll make part again a part. तो हमारा 2D स्केचिंग हो गया, 2D स्केचिंग का मॉडल एंड देन पार्ट मॉडल. ओके, नाउ विल टेक राइट प्लेन. फिर हमने जो बनाया था वहाँ पे 10 का सर्कल बनाया था. सो आई विल मेक अ 10 सर्कल ओवर हियर. एडिट स्केच डायमेंशन एंड दिस इज 10 mm. ओके, फिर उसको एक्सट्रूड करना पड़ेगा कितने से, 80 mm से. ओके, तो हमने 80 से वहाँ पे एक्सट्रूड कट किया था. सो 80 से एक्सट्रूड कर लिया एंड नाउ वी जस्ट मेक अ लिटिल this much bigger circle, features extrude. I think this much is okay. Okay, then again I will make a circle this much. Okay, feature extrude. Like this 10. Okay, 2 is good. Then I will make features convert entities. So this will be converted into sketch. Or I should not do convert entities. Again I will go edit. and with a circle a little bit smaller, I will delete this outer circle, features H2, and this one I will extrude it here. That's this much. Fine. Here is the Jacob square plane number. Okay, offset plane. Setting the plane till 30. फिर इस प्लेन को सिलेक्ट करके इस पे मैं आई विल मेक अ सेंटर रखूंगा. हमारा जो सर्कल है, दिस इज द सर्कल. ओके, एंड नाउ आई विल एग्जिट. आई विल हाइड द प्लेन. ये यहाँ पे स्केच बाकी है, इसको फिर मेरे को कन्वर्ट इनटू दिस करना पड़ेगा. सो दिस इज द स्केच. सो वी हैव टू स्केचेस. नाउ वी गो टू फीचर्स, the option called lofted. Okay, but now I'm not getting the guide curve, so I should draw one more thing. Which plane now? Front plane. Front plane sketch. Let's take the 3-point arc. Okay, so this much is enough. Yes, this circle, this point. Yes, control 8 again to go into the normal. I will just make this line into construction line, and I will mirror option. There is mirror. Yes, mirror into this. Mirror about this line. Okay. Now I will exit. So now I can do lofted with guide curves. So I will take this. Okay. Now in guide curve section I will take this. Okay, and this line. Okay. Okay. So we have our screwdriver ready now. Right. तो अभी हमारा हो गया है 2D sketching and part design. Now the next module is assembly. So I first of all save this. There is part 2 and part 3. Now again I will go to new and I will take assembly from here. Okay, now I import both of the geometries, both of the bodies that we draw. तो ये और ये अभी मुझे इसको मेट देना है. Okay, so first of all there is a I use circular mate, which means it is constrained over here but it can rotate. Okay, so this is important. And the second mate that we can do is this and this guy. Okay, coincident. Now for to give it, you can do isometric view. So this is isometric view. Now you can see this is too long, this is too short. So I will have to edit the part. Part edit में अपने को सबसे पहले क्या करना पड़ेगा? Okay, so this is I will edit this sketch. This sketch should be a lot more bigger. That's it. Now we'll extrude. We'll extrude इसको भी lot more bigger. Okay. I will edit this sketch also. इसको भी जो टूल बॉक्स में से this also has to be lot more bigger. I will edit this sketch also. इसको करीबन इतना रखते हैं. So Solidworks give you the editing feature. So it is very easy. यहाँ तक. और अभी अगर ये लास्ट जो है, अगर ये मुझे एडिट करना है, तो मुझे जस्ट प्लेन को स्विच करना है इधर से. ये बहुत पास में, so I will take it to the 40. Okay. Fine. Just save it. Now it's looking fine. अब जो है मैं इसको रोटेट करके सही जगह पे ला दूंगा इसे. Okay. So this is our isometric view. Now the next thing is material application. So we done 2D sketching, part design, assembly, and now it's material application. So I can open this part separately. I can go to material application. It will switch to the part mode. So now whichever material I will apply, it will apply to the whole board. I will go to plastic, high gloss. Let's take yellow. Okay. So this is the plastic, and now I will have to apply material only to this cutout feature. Okay. So I will choose that cutout and then the circular feature. And then I will go to material application. Okay. So now it has taken only those two features, and I will apply green color. Okay. So it's looking fine. I will just save it and exit. It will update here automatically. I will take this part. Now I will apply your material. I will go to again entire material selection. I will go to okay, metals, glass. No. Okay, this is fine. So I applied this material over here. Okay. Now again I will go to apply material, but I want separate material. Okay. So this is our face selection. Phase 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10. Okay. All features are selected. I will go to material application. Go to polish picker. You could polish over here. Brushed. I will go to scale. Stand. Just scale. Okay. This much is enough. I will just go to again isometric view, Control S, and it will update automatically. Okay. So now this is the real view graphics view. Okay. So the graphics are good. But if you don't want this, you can enter code over here and you will get this kind of view. Okay. So now it's fine. Now the next module that we'll do is motion study. That is animation. Okay. So here we have animation. I will just change the frame rate to 40. Okay. Then I go to motor. Now we have constraint here, coincident constraint. Sorry, concentric constraint, which means it can rotate along its axis. So I will apply rotating motor to this part and RPM I will change to 50. Okay. So now if I click to calculate, it's moving. So this kind of animation you can do. Okay. Now if I add another animation from animation wizard, which is rotational animation. Okay. Go to y-axis and the start time will take finish. Okay. And now recalculate. So see if it's moving, we can take. Okay. Now I can go again to the real view graphics. Isometric, motion study, play. So you can make this kind of animations also in SolidWorks. So it's a very handy software, very fast software. I will just install assembly over here. Now again I'll open the assembly cell. Okay. Now the next we will do is the next module that we'll do is space calculation, simulation. Okay, finite element analysis. So even simulation you can do it. SolidWorks. So I'll click at simulation. Then there comes the simulation tab. Go to new study, static study. Okay. So this is the part. Okay. Now first of all, the first step in simulation or finite element analysis is material applications. I'll go to material, plain carbon steel. On material, ABS mix, no plastic. I think brass is okay. Okay. And on the second part, now the material that we applied first before to this part is the visual material. But for the static study, we'll have to apply the original actual materials, okay, which we can apply from here. And I will take, I think this is okay. Okay. So after the material application, the next part is connection, fixtures. Okay, let's go to isometric view, fixtures. So fixed geometry. So before space analysis, we'll have to tell that which is the fixed geometry. Okay, so this much I will select. I will do this as a fixed geometry. And I will just hide it. Okay, so that dots gone. Now I will do the external load. I will take force. Force I will take along the selected direction. The direction that I am selecting is this direction. And force I will select along this edges. Okay, I think this much is okay. Now the direction it is coming out, but I want inside. So I will make reverse direction. And 1 Newton is the force. Okay, I will hide this also. Okay, now what I will do is I will generate a mesh. So to generate mesh, go here and create mesh. Now if you increase this, then the mesh generation will take more time. Okay, if you reduce, the mesh generation will take less time, but the results will be less accurate. So I will take in middle only and I will generate mesh. Now this depends on the power of your CPU, the time to create a mesh. Okay, so see the mesh has been created. We have given all the necessary conditions. Now the last option is to run the study, so that we will get the stresses which are going to be generated on this part. Alright. So see, we got the stress. So this is the value of the stresses, and this is a visual representation. So what I did is that when you will place a screwdriver against a screw with a force, what will be the stresses generated on the body that I have calculated? Okay, so if you place with 1 Newton, then these are the stresses generated. These are the areas. Blue areas, least stresses, red areas, maximum stresses generated. Okay, then displacement, the maximum displacement will be happening towards the knee, and this is about the strain. Now you can also animate this. You can go here and animate. Okay, now the frame rate you have taken the file, I take 40 for smooth animation. I will recalculate. Now we'll see it is calculating the frames. So it is calculating frames. Okay. So all frames calculated. I will just increase the speed. Okay, so you can do this kind of animation also. Alright. I can also calculate factor of safety. So from here you can go and okay, define space block. So cancel, right click, define factor of safety block. Okay, okay. So see, this is the factor of safety block. Alright, so I will just save it. Control S. Cancel. So now the next that I'm going to show you the next module. We have already done with 2D sketching, conversion into 3D part, material application, assembly, motion study, and simulation or finite element analysis. The next module is surface module. Okay, where we create complex surface bodies which cannot be created into part design that we can create into the surface. So I'll just quickly show you the surface. First, like top plane, sketch, circle. Okay, switch this to images. Now again, top plane, take a reference plane. This much is okay. Then again, this plane, sketch, a little bigger circle. Fine, exit. This plane, reference plane. Okay, then take this plane, sketch. This much. Okay, exit, again take a reference plane. We are making a what kind of structure, okay? And again here this much, okay? Then exit and again take a reference plane. And on the last plane, again draw a structure, okay? This much. And then just exit, hide all the planes. Okay. So this will be. I can just make a lofted surface. Select this circle, and this circle. What kind of structure? Okay. One can say that this structure can also be made with the revolve command. So complex structures, for example, I will just delete this. Now if I have a guide curve, I'll take right plane sketch. Okay. So this is a spline tool, spline lines. So I will just draw by reference. The very important thing is to make this coincident or pierce. Okay. So this point pierce with this point pierce with this point pierce with this point pierce with this. Okay. Then control H for normal view. Again this spline tool with reference just to draw. Again do pierce, 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 and pierce. Okay. Now if I just move this a little like this line a little like this. So this is a complex structure now, okay? And now if I use the lofted surface, selecting all the circles and then selecting the guide curves. Okay. So see, these kind of structures cannot be made with the revolve workspace command. Okay. You can just edit the sketch more. See, this kind of structures cannot be made with the revolve workspace command. Okay. And once you are done with the surface command, just go thicken it to outside. Okay. So this is converted into solid body now. You can also tap the faces on the upper and the bottom side. Okay. Now I'll just control Z it. Now okay. So what I will do is I will just delete this. I will have to first delete the interlock, then delete this stage. I will go to features and I will do a solid modeling. So select all of the faces. Okay. Now just select the right plane, sketch, take the outside point, vertical line. Again a line, take the middle point, center point, this much, and make this line, construction line. Now features, okay. And I will make the thickness 5. Okay. So see, I made the cap. Now it's of too height and too much thickness. So I can edit the first level 3 and then edit the sketch, make reduce height, exit. Okay, so you can also make threads. For thread you have to go here, take helix and spiral. And after this, exit. Okay, so now clockwise, counterclockwise, revolutions, more, pitch and revolution, and pitch will reduce to 2. 2 is okay, 10. Okay, and then you just make it onto the reverse direction. Okay, this is reverse direction. Then to reduce the revolutions. Okay, this much. Okay, so I just want to show you the sweep command. Sweep command is here. What is sweep command? So with sweep command you can make the threads also. Where is the end? Okay, let's make from here. Now we'll take a plane on this point. Okay, plane. And we'll take a reference plane of. Okay. So I will take a plane. This point. Okay. Then I'll do a sketch. I have to create a sketch outside. Just take swift pause space. Select this profile. Circular profile. Select. Okay. Then we try to reduce to 2 or 5. Okay. So write both of them. So this kind of you can also make the threads with the help of the sweep pause command. Okay. So what I will do is I will just delete all these commands. I'll just delete also this revolve. Okay. So now the next, so we also done with the surface command, the surface module. Now the next module that we are going to see is the mold tools. Okay. So suppose this structure if I want to manufacture, I cannot manufacture this with the help of the machining. I will have to manufacture this with the help of the molds. So for mold, I will need the exact dimensions of the molds. Okay, exact dimension of this part. So it's very hard. First, I will have to manufacture this part in real life. Then I will have to calculate the dimensions, and then I will have to create the mold according to that. But we can do that in the SolidWorks very easily. So the first thing that we have to choose is from which plane we need the mold to separate. So I will choose right plane over here, right plane, and this will be your split line. Okay, choose the surface on which you want to split the body. So right plane has splitted the body. So this is your parting line. So go to parting line. Now select which plane we selected. We selected right plane. Draft analysis, and see it is selected already. Selected the edge. Okay, so select this edge. Okay, so we have a part. Okay, so we have created the parting line. Now we'll create the parting surface. Okay. Okay, so this much is our parting surface perpendicular to the tool, right? So we have parting surface now. Now we just have to make the tool split. Then I choose right plane. Now here I'll make a geometry of the mold. So I'll take from here vertical line. Again here this much line, right? And I will just mirror it onto the other side. So from here I will take this line, make it a center line. I will choose all these entities over here, and we'll go to mirror about this line. Okay, and just mirror it. Okay. So made the entire structure of the mold. Again to mold tools. I will exit. I will choose this sketch, go to tool split. Okay, so this is our mold. Reduce the dimensions from here and see now we have created the mold. I'll just hide this, hide the parting lines also, which I can hide from here. Okay, so now if I want to see the mold dimensions, how will I see? I will go here, go on to the solid bodies, transparent, transparent, hide. Okay, so see this is the mold. So I can just import this into AutoCAD, or I can take the dimensions from drafting. You can also draft, that is take out the dimensions from the SolidWorks. Okay, and then I can give it for the manufacturing of this mold, from which I can manufacture the pot. Okay. So I will just save all the bodies first. I will just change the transparency. All right. Right click, save bodies. So first of all, we'll have to save this entire assembly. Okay, so this is part 4. Now I can right click, save bodies. Save. Okay. Okay. So just meaning change. Now go to again new assembly. So now we are going to make the exploded view animation, which is very important for making mold animations. Okay. So just open all the 3 parts. This one, this one, this one. You will also learn the mates, which is the face mates. Okay. So first of all, I'll take this face and this part, and I will make the mate. Which kind of mate I'll make? I'll make the plane mate. So where the 2 planes are making coincide. Okay. So I'll choose this plane, front plane, and front plane, and mate. So see, they are aligned together. Then I will choose top plane and top plane mate. So again, they are aligned together. Okay. Then I will choose right plane and right plane mate. So see, they are aligned together. Okay. Now the next mate I will do is I will just minimize this one. Okay. And I will go again front plane and front plane mate. Okay. And then again top plane and top plane mate. Okay. Then again right plane and right plane mate. Okay. Okay. So the top plane and top plane are not made together. Top plane and top plane mate. Okay. Then see. Now I can do here exploded view animation. So I will just drag it outside. Done. Drag this outside. Done. Drag this onto the left side. Done. And drag this a little bit up. Done. Okay. So we have our exploded view. Now right click on here and make collapse. Now you can animate from here itself. You can animate the explode. Okay. But now if you want to animate it entirely, that is explode as well as collapse, what you will do, you will again go to motion study, then animation, increase the frame rate to 40, go to animation wizard, take here explode. Okay. Explode will from 1. I'll just increase the time to finish. Okay. And then again make animation wizard, this time collapse. I made 7. So 7. And again here 7 seconds. So the start time is 7 and the duration is 7 seconds. Okay. So till here it is exploded and here it is collapse. Okay. So see, This is the animation. Okay. Now you can also save this animation. So I will just quickly show you how to save the animations. I will take MP4 file. The resolution will be 16:9. Frame rates will be 4p. Okay. The entire animation. Correct. Everything is correct. Here only I'm saving. Okay. Okay. Save. So now it will calculate the entire animation. Okay. Remaining very little. Okay. So see, now I calculated the entire animation. Now we'll just see where is our save location. So see here it will be the, yes, this. So see, this kind of animation you can make and which you can save on the PC itself. Okay. So now the next module, we already done with 2D sketching, then part design, then assembly, motion study, material application, simulation, now old tools also, and exploded view animation also. So now I'll take a new part. Okay, take a new part. Now the next module that we're going to do is weldments. Okay, SolidWorks weldment. So this is very important to make the stairs kind of structure. Okay, the industrial stairs. I will just put the photo at the end of this module that which kind of parts can be made in the weldments. Okay, so I'll just take front plane sketch. I'll make this to MMJs. Again go front plane sketch line. Okay, now go to weldment. First exit the sketch. The structural membrane. This one, this one, this one. Okay, so see. Now if I had to make this part in the part design, it could have taken a lot more time. But because of the weldment model, I made it just in 1 minute. Okay, I can also edit the sketch. So we'll just increase the height a little and increase the length a little. Okay, exit. So I made this. I will just mirror. For mirroring, we'll have to go to features, mirror. We'll select bodies to mirror. These are the bodies. We have not selected the plane, so first we'll have to create plane. We take front plane, then we'll get a reference plane for that. Onto the offset side. Okay, this much is enough. So along this plane, we'll have to mirror the bodies, which are these bodies. Okay. So I just mirror them. Then hide. Now I have to create pattern in between. So what I will do is I will take a top plane sketch, go to line. Okay. So I created this. Now I'll again go to weldment, structural membrane, select that time and see. I want this to be horizontal. So I will go to alignment. Along this, I will switch. I want this to switch inside of this. So what I will do again is I will go to locate profile, select this point. So it is taken inside. Okay. So see this kind of structure. Now I will also show you the linear pattern. So I will just go to patterns. So see, this is linear pattern. Okay. Now I'll select bodies. This body I want to pattern. But along which, okay, so let us select the, so it first asks for the direction. So select this direction and then the, okay, bodies, stick bodies. And I'll just reduce the number. Okay. So correct. So see, so this structure we have made in the weldments. I can increase this to real view graphics. I can off the real view graphics also for better visualization. Okay. So this we have made, and this could have taken a lot more time if we could have made it in the part design. But because of weldments, we can make it quite fast. Okay. I will also save this. Okay, so the next module is SolidWorks piping or SolidWorks routing. For that, we'll have to open assembly. Now come here, the piping section, go to design library. From here, you will have to choose, for example, so from design library, you will have to choose routing, then piping, and then from here, first I will take flanges. Okay, so I will take a flange. Yes, you'll have to save the assembly. Okay, and then with OK from here. Okay, so I just increase the length. Now we'll take a line. Now we are into 3D drawing mode. Okay, so see, so much axis we have now. So first this, okay, and this, Okay, now take a line over this point. We'll snap the line over. So see, we have snapped the entire line. Okay, now I will again go to the design library, take the T's. Okay, so zoom in over here, add a T over here. Press tab to increase the to change the direction. Okay, and okay. So see, now you have added the extension over here. Also one over here. Okay, correct. And one over here also, but in the opposite direction. Okay, so now again I will have to add flanges because at the end of every pipe there is a flange. So take a flange here, add okay, here again, and here. Okay, and the next thing that we can add is okay. So we'll add valve. I will take this valve bit well, add over here. Okay, and another location where I can add is here. I've added it. Okay, again exit. Okay, so it's fine now. Okay, go to the isometric view. So this kind of pipe structures also you can make in SolidWorks. And even if this we have to make in the part design, it could have taken a hell lot of time. But you can make it over here at very fast rate. Okay, so just exit and see. This is our part. Okay, of the real graphics, and you can just hide the routes from here. Okay, just hide the entire geometry. Yes. So see. So this is SolidWorks piping or SolidWorks routing. Now we move on to the next model. So okay. So you have to on the drafting from here, drawing. Now you have to choose the paper. So I will choose here A3 landscape. Okay. From here you can say, okay, so now it will show all of them. Okay, so this I choose. Okay. So this is the drawing window. So I'll go from here view palette. I will browse my part. So which part I want? The inverse two drawings. So I will take. Okay. So we'll take the mold. So this mold dimension I want. Okay. So I will take this view. Escape delete. Again go to view palette. Okay, so this is the front view. So this view. This is the side view. This view. Okay, so that's enough. Now I can select it from here. I can make it colorful, or I can make it with hidden lines. Okay, so see here comes the hidden line about how it will look. Okay, now the next thing that I can do is I can give dimensions. So I will choose this. I'll go to drawing and sorry, annotations, smart dimensions, and choose here auto dimensions. Okay, so see these are the auto dimensions and they're given to this part. Now if I don't want this much of dimensions, what else I can do is I can select manual dimensions and I can do it from here. Okay, so this part, this dimensions. Okay, so because we made a parting line, so I cannot select this dimension directly from here. Okay, because while selecting first we made a parting line, na? That's why I'm able to select this. Okay, so now again, so I will save. Okay, so we are done with the drawings now. I will again take a last drawing. I will also show you how to convert it into PDF format. Okay, so we'll take part 3. Open this one, this one, this one. Only 3 views are enough. Okay, this I will make in high quality. Okay, so there are no hidden lines. Go to dimension. This will be the distance from here to here. Okay, the distance between both of these. Okay, so now the thing is that the dimensions are looking very small. So I can edit the font from here. Go here, font, choose your points, choose 26. Okay, so the dimensions are good. Also the part are looking very small. So I can go from here. I can use the custom scale. It is 1 is to 2. That means 1 is to 1. Okay, so the parts are not clear. I think 1 is to 1.5. Look at make 1 is to 1. We'll move this out and move both of these also over here. We'll come into all the dimensions. Okay. So now because the dimensions were in meter, now they were very small. So because I removed the decimal points, so they are showing everything at 0. So then I will increase the decimal point. Okay, so now they are showing the dimensions. Okay. So now I will save this. And while saving, you can save as in PDF format. You can come the PDF format. The drawings. So see, this is the PDF format. Okay. So this you can send to the manufacturer with these dimensions, then he will manufacture the part. Okay, he will do the fabrication. So these engineering drawings are also very important, and this also you can do it solid. So this is also one of the module, very important module. Okay, so far we have been done with 7 to 8 modules of SolidWorks. So you should understand that how vast this software is. So our next module is render tools. Okay, so I will open one of my projects. Go on open, view, drawing, Sterling engine, S23 open. Okay, so this is a Sterling engine that I made. It took me over 3 hours to make this. Okay. Now for render tools, what you have to do is you'll have to go into SolidWorks add-ins, and from here you will have to on the render tools. The next thing that you'll have to do is go into add-ins from here, and here you will have to add PhotoView 360. Okay. So this PhotoView 360 has been added. Then here you will have to find render, yes, render tools. Okay. Now from here, first thing that you will have to options. You have to go into options. Here you will have to adjust the resolution, the type of image format, the quality of the render. Okay, so the more quality you're going to take, the more time the rendering will take, but please and good results will offer. So after making this okay, then you will go into the render region. Okay, so from here you will select how much region you need to render. The next thing that you will do is go for the final render. Here you will add a camera. Okay, so this is the camera. All right, you will adjust the camera a little bit. You will make okay from here, and then you will do the final render. Okay, so the next module which we are going to perform is a very important module, which is the sheet metal, which has immense demand in the industry. Okay, so we'll take a new part. Then I will take, okay, so I'll take top plane, stage. First of all, I will change this to millimeter. Okay, then we'll take top plane, sketch, go to a center rectangle. Here, this much. Then go to sheet metal, this much. Okay, this much. Now I'll take this option. Okay. Okay, so I can do all of these kind of tricks. I will take this. Okay. Now I'll just do, this is, the length is too much, so I will just edit it. So from here I will edit the length. I will take this much length, exit, it will automatically regenerate. Now I will take edge flange. From here I will take, I can edit this edge flange. First of all, I will change the radius. Let's take the radius here from 2. Okay. So the radius has been updated automatically. If I take 5, see, it is updated automatically. After taking the radius, I want to edit this flange. So what I will do is I will go to edit flange. So this is the sketch is valid. I will delete this line, delete this line, take line from here, take to here. Okay. Next line from here to here. Okay, then go to trim entities in both of these parts. Okay. Now I'll just make a circle. Now the midpoint and this one, make vertical. And this circle tangent with this line also tangent, and with this line also tangent. Then I will go to edit this part, and this part. Okay. Now this point I will have to make vertical with this point. Okay. So I will just finish it. It will automatically regenerate. Now if I want to make a cutout in between, so I make a circle. Now here in the sheet metal also I think you have extruded cut. Okay, here. So I can extrude cut it over here. Now in real life this part is made up of a sheet metal. then it is having bare minimum thickness. So I will have to provide a gasket over here. Okay, that's it. So in order to provide strength, so that option is here. Select both biggest and same. Okay. Now, okay, so that's okay. So this is a sheet metal. That's it. Now I can increase the number. So I will just select it. Go to features, linear pattern. Along this, I will make the number 2, 3. Okay, push P5. Okay. So see, these are the sheet metal. That's it. Okay. Now I will again go to sheet metal, H flange. This side away and H flange. Again, the radius by default, they are not taken properly. Now I can take this H flange from outside, from inside. When I take it from inside, there will be a relief created. Okay. Okay. Now suppose I want to hold over here. So for that, I will have to first flatten. So I will do unfold. I will have to unfold from here, and the bend, I will select this bend and it will unfold. Okay. Now I can draw again here. I will go to a straight slot. Okay. So this is the slot created. Now go to features, extrude cut it. Okay. Now we'll again go to sheet metal and fold it back. So this and this is the bend. So see, it has been folded back. Okay. Okay. So what next? I can take off sheet metal. Going to okay. So this much is enough. So this is the sheet metal part that we have created. Now, in order to manufacture this part, first of all, we'll have to flatten the part. Okay. So we have flattened the part. I will take a top view and change the views to these lines. Okay. So now this part I will go and go to the manufacturer, and this extra material, the extra material will be saved because I manufactured, because I have made a proper drawing to the manufacturer, and this will reduce our cost. Okay. So here also this software is very important in sheet metal as it helps to reduce our cost and to increase the speed. And again I will change the view to shaded with edges and take isometric. Okay, so for now the next model is the evaluate tool. So we created this element part, but we don't know the dimensions. So in order to know the dimensions, what we'll do is we're going to evaluate, then we're going to measure. So if I select this face, it will give all properties. For example, the area, the parameter. I want to know the distance between this face and this face. Then I will select both the faces and it will give the proper distance. Okay. So this is also very important, the evaluate tool, when we want to measure the mass properties. Okay. Now the next thing is the section view that I want to explain. So if I go into section view, then this is the section view where I can see the section view of the entire assembly or entire part. Okay. This is also very important for visualizing the part. So I will take text, add on to this space, type here. Okay, so the text has been added over here. Near the page, select this. Okay. So here comes the text. Now I want to increase the font. I will go from here, take points, select, put here. Okay, so that's here. The next thing I will do is make it bold. Everything is correct. Okay. I'll just go feature, extrude boss. So see, the name is extrude. So I'll take here. Okay, this much is enough. Then I'll just hide this line. And this feature I want to make color. So I will take a red color. Okay. So I have embossed my name onto the part. So because I have my name on this part, then this is the proof that I have not downloaded this part from online. Okay. To control this. So this is also very important. Okay, so the next very important feature in SolidWorks is that we can add the daily use part. Okay, so you can go here in design library toolbox. Then in toolbox you can go ANSI metric. Now for example here for bearings. Okay, so you can call bearing. Okay, see. So you will not have to make this entire part. From here you can add and you can also edit. Okay, so this part only you can edit the features from here. Okay, no, these parts are not editable. The next thing you can add is, for example, volts. So this is see. Another thing you can add is you can go into gas. For example, power transmission gas. Let me take the helical one. Okay, so see, this is a helical gas. Because I'm adding these gears, I cannot, as a part, I cannot edit that. For example, if I take this, I'll put this into the assembly. And here, for example, if I add per gear. Now see, here I can edit. I can increase the number of feet to 45. Increase the model. Okay. And increase the face width. For example, if I take 40. Okay. So here I can edit the parts. Extreme that I can add is there are O-rings, there is a nut, so you can add nut also here. You can edit it. So they're editable only in the uh, assembly section. Okay. Next part, there are washers, rings, O-rings, nuts, bearings. So these all things you can add. Okay. And these are all the standards. There is a Japanese standard, Korean standard, Indian standard, and this is American Engineering Society. Okay. The metric and inch for Korean standards.
Okay, so the next module, the last module is the SolidWorks CAM module. So when a 3D part is created, it has to go under a series of operations such as milling, drilling, grinding in real life, in order to obtain the required geometry. Now the path that the tool is going to follow to generate the geometry, to generate the part, that path we can simulate in SolidWorks, and that is known as SolidWorks CAM. Now SolidWorks CAM is extremely important and is very complicated. So here I'm going to just give you your overview. Now the resolution of the video is little less, so bear with that. So first of all, I'm drawing this geometry which I'm going to perform the CAM. We are also going to understand the cutting path generation, CL file generation, and the G and M code generation, which we are ultimately going to input into the CNC machine, okay, which will give us the part. So I've drawn this geometry. I've drawn two holes, extrusion of different lengths to make the geometry a bit complex. Okay, I will also draw a circle over here, and I will extrude it up to a 50 height. Okay, now the SolidWorks has to be add-in through the SolidWorks add-ins option. Now I am selecting the machine. The machine I have selected is a milling machine. Okay, now the coordinate system I have given. While giving the coordinate system, one should ensure that the z-axis is always up. Now this is the stock material application, from which now there is milling operation. So I will select the topmost face and see it has generated the code. Okay. So now the last, okay, so now this is toolpath generation. The path that it is going to follow, and now this is the ultimate simulation. Okay, how the milling operation will be done and how these features will be embedded on the job. So SolidWorks by itself, it recognizes for which features how the toolpath should be generated, but it is customizable, so you can customize the sequence of the operations according to your requirement. This is highly complex. The main software which is used for CAM, computer aided manufacturing, is MasterCAM software, but SolidWorks also offers a great edge in SolidWorks CAM. Okay, so you can increase and decrease the speed of this animation, and this is very helpful in presentation. So this is the actual path that the VMC machine will follow. Okay, now this is the cutting file location. The cutting file is the jobs that we are going to perform, the feature, the sequence. Okay. Okay, so we have just generated the cutting file, and now this is the generation of the G and M code. Okay, it has to be saved into the tab format so that it can open into the notepad. So this is the G and M code which you can directly input into the VMC machine, and inputting the job of the stock material, you can just on the machine, and given this code, the machine will form this part.
Okay, so now we have been done with all the modules of the SolidWorks. So these are some of the projects that I have done in SolidWorks. Okay, so this is the umbrella mechanism. See this kind of mechanism. Okay, then this is the sheet bending mechanism. This is a very good animation which is showing how the bending of the sheet. Okay, now this is the animation of a motor. So this is also very good. It took me over 1 hour to make all the parts and assemble them. All right. Now, so this is the pen, cello gripper pen. This I made by myself without any dimension. This is free modeling. Okay, this is of no dimension, without any dimension. This I will change the transparency and I will just suppress the part. This is the part. I will just suppress it. Yes. So see, this is the pen. Okay. Don't save. See, this is the sheet metal part that I made. This is a hopper. Okay, hopper design. Then this is the vent, the industrial vent. Okay, for air conditioning that we use. This is also made of the sheet metal. Now this is the gear. This I made with the help of the toolbox. Okay, so see, this is the animation. This is the gear made animation. Now this is the mold making. So this is made with the help of the mold tool. Here also I give the animation. For example, see. Oh sorry, here I did not give any animation. So I just animate it with the help of this animate collapse. Okay, see. Mold tool is also very important. So now this is the my mechanical fourth year project. This is a garbage collection mechanism. Okay, automatic garbage collection mechanism. So in the conventional way, there are people inside who collect the dustbin from you, so they have to be in the garbage all day long. So this is the mechanism which is used, which I'm making to replace them. Okay. So see, this way the dustbin will go inside and then it will come back. Now this is the bobcat. This is the biggest assembly that I've ever made. This took me over 7 to 8 hours to completely make this bobcat assembly. Okay. So I hope you learned a lot. The main aim of making whole video was to introduce you with the capabilities of the SolidWorks. So this is a very important software, and I hope that with watching this video, you will have developed interest in learning the SolidWorks. So I think that with this watching this video all along, you would have understood the importance of this software in mechanical engineering. You would have learned a lot and would have developed some interest in learning the software. So that was my main aim. The aim was not to teach the software. The aim was just to introduce you with the capabilities of the SolidWorks software. Okay. So thank you for watching.